So the first thing we need to do for the bell ringer is write it in standard form. So what has the highest exponent?
-2.
Okay, next, -2x to the fifth. And then we have -3x to the third, is that right?
Yep.
Plus 5x squared, tell me if I'm wrong. Plus 9x plus 1. Okay? So what is my leading coefficient here? It is -2. And what's my degree? The degree is 5. So the answer is up, down. Or up, down. I'm going to save your homework to go over tomorrow because I forgot to go over it in my last class too. Actually, no, let's go over it real quick. I just want to check it off. I'll save that. Well, this won't take me very long because it wasn't that difficult. Okay, so what'd you guys do on 8 through whatever? Did you just write in standard form and degree and leading coefficient?
Yeah.
Okay, number 8, 10x plus 5. The degree is 1, leading coefficient is 10. Number 9, -3x plus 5. I'm going to pause this. Our whole goal and what we're trying to build up to, and I think we started on Thursday, is to graph these polynomial graphs. So yesterday, you guys learned how to do the end behavior of the graph. Today, I'm going to show you how to find the zeros or where it crosses the x-axis of the graph. We're going to have to do this by factoring, our favorite thing. So let me jump right into the first example. X cubed minus 2x squared minus 15x. And I want to find the zeros or the x-intercepts or where it's going to touch the x-axis. So we're going to have to factor this. First thing you want to do for 3 terms is look for something you can take out. What can I take out of all 3? An x. So I take an x out, and I'm left with x squared minus 2x minus 15 equals 0. Am I able to factor this using the shortcut?
Yes.
Why?
Because there's the first one. First x.
Because the a term is 1. As long as the a term is 1, you can use the shortcut. So I'm looking for 2 numbers that multiply to give me -15, but add to give me -2. What are they?
-5 and 3.
Very good. -5 and 3. So we can jump to our factors. We have this x out front. And then my 2 factors are going to be x minus 5 and x plus 3 equals 0. Now, what do I do with each factor to solve for x? What do I set it equal to?
0.
Set them equal to 0. So I have x equals 0. That was easy. X minus 5 equals 0. So that means x is equal to positive 5. And x plus 3 is equal to 0, which means x is equal to -3. So these are all of my zeros for my function. So really there's nothing new, it's just bigger. There's something to factor out. It's just a little bit bigger. Here's what we're finding. You don't have to write this down, but here's what we're leading up to. If I'm going to graph this polynomial graph, I know 2 things right now. I know that it's going to touch the x-axis when x equals 0, when x equals 5, and when x equals -3. I also know what my end behavior is going to be based off of my original equation. So this is an odd positive. So what's the end behavior for an odd positive? Goes 2 different directions, down, up, because it ends positive. So I also know that this graph looks like this. I don't know what's going on in the middle. That's what we're going to lead up to. I don't want to steal my thunder for Thursday. But this is why we're doing what we're doing. Oh my gosh, I just hit the turkey foot. Stay over there. This is why we're doing what we're doing, because we're finding the x values. Okay, so it's not just because it's math and we throw something else at you. This is what we're leading up to do. So let me give you one to try on your own. X cubed minus x squared minus 12x equals 0. factor something out first, do the x method, get your factors, set them equal to 0, solve for x. I gotta make sure I wrote down to go over work tomorrow. Okay, so I factor out an x first. I can do the shortcut because my a term is 1. So I'm looking for two numbers that multiply to give me negative 12, but add to give me negative 1. Negative 4 and 3. So I have x minus 4 and x plus 3. So I have x is equal to 0, x is equal to 4, and x is equal to negative 3. Good? All okay with that?
How'd you get the 4 and 3 then?
Because I was multiplying to get negative 12, but adding to be negative 1. So I had a negative 4 and a positive 3. I just didn't write the x out. Okay? Now, we're going to do another one like this, but something magical is going to happen. No, it's not really magical. It's not even that exciting, so don't get excited. But let's pretend I have x cubed minus 2x squared minus 4x plus 8. And I'm solving for x here. So when I have 4 terms, I factor by what? Starts with a G. Gur. Gur. R.
Greatest common.
No. Kind of. Kind of. We are one big math group. We factor by grouping. Okay? And we take out the greatest common factor. So, here in my first group, I'm going to take out an x squared. And I'm going to have x minus 2. What do I take out of my second group? Negative 4. Leaving me with x minus 2 because I divided that out of there. So my factors are x minus 2 and x squared minus 4. Everybody good with that so far? But what is x squared minus 4? Did I go too fast up there? It's a difference of 2 squares. Good. We got to that one quicker. Difference of 2 squares. So, when I have a difference of 2 squares, I have the plus and the minus. And I have x plus what? 2 and x minus 2. So here are my factors. These 3 factors. I'm going to set each equal to 0 and solve for x. So when I do that, I get x is equal to 2. I get x is equal to negative 2. And what do I get in my last one? X is equal to 2 again. This affects our graph because do you spy the same thing? Do you spy twins up here? I spy twins right here and right here. So here's how you write that for today. When I write my factors, I'm going to say x equals 2 with a multiplicity of, how many were there? 2. If there were 3x equals 2, you'd write with a multiplicity of 3. And then you'd have x equals negative 2. So this would be your answer. Because the multiplicity matters when we start graphing. The multiplicity of 2 does something to the graph. So for today, you're not doing any math. You're just doing exactly what we've done. But if you see 2 or 3 or 4 of the same, you're going to write that fact or that answer and then say multiplicity of how many you see. Easy enough? Okay, now we're going to go backwards. Yay. Now we're going to go from here back to here. So we're going to start with our roots or our zeros, and we're going to end with the equation that we started with before. I'll make the first one easy, and the second one we'll math up just a little bit, but not very much. So here I'm going to give you x is negative 2, x is equal to 2, and x is equal to 3. So I'm thinking backwards now. When we went to, over here so I'm out of your way. When we do this, here I'll go to this one because it's cleaner. X is equal to 0, that was just an x. When I had x is equal to 4, that was an x minus 4. And to get x equals negative 3, I had an x plus 3. See how we had to do the opposite each time? So down here, I want to go, we're working our way backwards. So we're starting with these, and we're going to write them as factors first. So if I've got x equals negative 2, what's that factor?
X plus 2.
Very good. X plus 2. And x equals positive 2 would give me a factor of x minus 2. And then x equals 3 gives me a factor of x minus 3. What does your gut tell you need to do with these? Does it tell you anything? What'd you say? Okay, you're going to multiply these two together, and then you're going to take that answer and you're going to multiply it with this one over here. So you're going to end up with what you just said. But now I have a question because I want to see how much I have to emphasize, or if I can just go with FOIL method. Did you guys do the box method to multiply this, or are you stuck on one way is what I'm wondering? No? You're an open book. You're ready for me to mold your mind. So I can just FOIL and you guys are okay with that. Okay, I do have my next example, we're going to end up having to do the box method. But for these, you can just FOIL. So what I mean by that is I'm going to multiply the first two together first. I'm going to use the FOIL method. So I'm going to multiply the first terms together first. So I get x squared. Outer terms, I get negative 2x. Inner terms, I have plus 2x. And my last terms, I have minus 4. Some of you guys are able to jump right to this answer, and that's okay. If not, just do the FOIL method. What happens to these two terms? Okay, they're going to simplify out. So I have x squared minus 4 when I multiply those first two together, and I still have this x minus 3. Everybody okay with that so far?
Why couldn't you just write x squared minus 4?
Yep, if you can tell that this is going to go back to this, that's fine.
Okay.
So difference of two squares are easy to see. If it's not a difference of two squares, I would probably say write some of this out so you don't make a mistake. But difference of two squares are easy to see because foiling undoes factoring. So if I factor this, I go back here. If I FOIL this, I go back here. So that's fine. Okay, now I've got to do the same method with these two. So I multiply the first term together and I get x cubed minus 3x squared minus 4x plus 12. And this is my answer. And if I were to factor this, I would go back to where I started. Easy enough? So we're going both directions today. We're taking an equation and we're finding its roots or its zeros, and then we're taking the zeros and we're working back to the equation. So our brain's going to go two different directions. But I only gave you 5 questions today. Okay, I want to do one that's a little bit harder though, just in case you run into one like this. Not even that difficult. But this is one I use the box method on. Let's say x is 1, x is 2, x is negative 3. Let's write the factors together. What is the factor for x equals 1? Okay, and then I'd have x minus 2. And what's my last one going to be? Okay, x plus 3. Here's what I want you to do, so you can try some on your own, but don't go ahead of me. Do the first 2 and then stop. Okay, so FOIL the first 2 on your own. Make sure you're foiling correctly, and then stop. Okay, let's see if we got the same thing when we FOIL them. Okay, so I should have x squared minus 3x plus 2. Yes? Yes? Okay. And then times, I've got this other factor I haven't multiplied yet. How does this look different than the last one we did? Okay, this is a trinomial. Instead of the last one was a binomial. It only had 2 terms. This one has 3 terms. When you're having to multiply and you have 3 terms, you can't FOIL because you have a middle. You can't do first, outer, inner, last because you have a middle. But what I always do, you can double distribute, but it's easy to make a mistake. So I always go back to the box method when I have 3 terms. So the box method would look like this. X squared minus 3x and a positive 2. So put all the terms on the top of the box. And then x plus 3 on the side. And then just multiply each box together. So x times x squared would be x cubed. X times negative 3x would be negative 3x squared. X times 2 is 2x. 3 times x squared is 3x squared. 3 times negative 3x would be negative 9x, and 3 times 2 is 6. Then after we've multiplied each piece together, we just combine like terms. I have my x cubed. What happens with my x squareds? Okay. And then my x's, negative 9 plus 2 is minus 7x, and then plus 6. And that's your answer. Not too bad, huh? Okay. The work I have 5 questions for you today. It is in the book, but I have kind of some special. First of all, if I told you to do x times x plus 2 quantity squared, don't write this down. And I said solve for x. This quantity squared means I write this x plus 2 out 2 times. Okay? So that will give you a multiplicity of 2. So you guys can grab your books if you want. This is Erin Hanson. Hi. All right. Is she leaving? Okay. Oh, okay. Okay. All right. Bye. You're heading out. What's the? I'll put it in. Simmer. I'm going. I was just thinking, is all of the basketball team leaving early?
Yeah.
They do leave early today? Okay. That's what I was getting in my head. Okay, so 7, 8, you're just going to solve for x. 23 is the one where you write the equation, like the last examples we did. And then 28 and 29, we're solving for x also. But this one's going to have a multiplicity. Okay? I am checking this off tomorrow.